Hi everybody. So in this video, we're going to look at using differentiation to find when a function is increasing or decreasing. So we're told that the diagram shows a graph of y equals f of x. And we'll use this example to get a visual idea before we move on to differentiation. And we've been asked to work out the values of x for which the curve is increasing, decreasing, and then for which the curve has zero gradient. So as we progress through in this video, we're always going to take x to be travelling in a positive direction. And then we'll be looking at how the graph changes as we move in this direction. So to find the values of x for which the curve is increasing, we want the curve to be going up as x travels to the right. And you can see that this is starting from here as we travel up to f of x equals 4. You can see that this will always have a positive gradient because this function is increasing. But this also increases as we travel on in this direction. And again, this part of the curve will always have a positive gradient. So what we say then is that f of x is increasing when the gradient f dash of x is always greater than 0. So we'll say that x is less than 1. It cannot be equal to 1 because at this point it's neither increasing nor decreasing. And when x is greater than 3, as we travel to the right from x equals 3, the graph will keep going up. So x is less than 1 and x is greater than 3. And then to find the values of x for which the curve is decreasing, this is when x is greater than 1, but less than positive 3. And this is where we have a negative gradient. So f dash of x must be less than 0 when x is less than 3, but greater than 1. And then to find when the curve has 0 gradient, that will be at this point and this point. And we call each of these stationary points. So when f dash of x is equal to 0, we have stationary points. And for this question, this will be when x is equal to 1 and x is equal to 3. Okay? Let's try the next example. Okay, so in this example, we're told that a curve is given by y equals f of x, where f of x is equal to this. We've been asked to work out the range of values of x for which this is an increasing function, a decreasing function, and has a stationary point. So the first thing we need to do is we need to find the gradient function f dash of x, which means we need to differentiate this with respect to x. So f dash of x will be equal to, when we differentiate with 2x cubed, we get 6x squared. When we differentiate with 9x squared, we get minus 18x. Differentiate with 12x, we get 12. And this constant will go. So now we need to find when this equals 0. So we'll set f dash of x equal to 0, and then we'll solve this equation. But you can see on the right-hand side, we can factor out the 6. So we get x squared minus 3x plus 2. And then we can factorize this. So we get x minus 1 and x minus 2. So our roots are when x equals 1 and x equals positive 2. So what we've just found is that f dash of x will equal 0 at x equals 1 and x equals 2. And this will give us our stationary points. So I'll mark these on the diagram. So for part A, when f of x is an increasing function, as we travel to the right with x, this will be this part of the curve. And when x is greater than 2. So for part A, this is an increasing function when x is less than 1 and x is greater than 2. For part B, when f of x is a decreasing function, this will be on this part of the curve as we travel from 1 to 2. So we'll say that x must be less than 2, but greater than 1. So we know the stationary points then must be at x equals 1 and x equals 2. Okay? Let's try one more question. So for this question, we've been asked to show that the function f of x, given here, is decreasing for all values of x that are elements of a set of real numbers. So if it's decreasing, we know that f dash of x must be less than 0. So the first thing we need to do is to expand out this bracket so we can differentiate this f of x. So f of x will equal 5 minus 3x cubed minus a 2x. And now we can differentiate this. So f dash of x, this constant will go. When we differentiate the negative 3x cubed, we get negative 9x squared. When we differentiate the negative 2x, we get negative 2. So from this point, we can factor out this negative. So f dash of x will equal negative 9x squared plus 2. Now we know that this x squared term must be greater than or equal to 0, because when you square a negative, we get a positive. So if this is always positive, and when we multiply it by this negative, it will make the positive into a negative. So therefore, negative 9x squared plus 2 will always be less than 0 for all values of x that are elements of a subset of real numbers. So we've shown that f dash of x is less than 0, therefore it is a decreasing function for all real numbers. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.